And sound looks good. We're ready to go. Okay, come on. There we go. Okay, so like I said, we're doing 3.7 multiplying polynomials. And the first example here should be grade 8 algebra. Should be a kind of a review for you, a refresher. We call this the distributive property of algebra. When you're doing algebra, bedmass never goes away, right? Bedmass rules still count. But notice, if I told you I wanted to simplify this expression here, notice that I'm kind of stuck. Bedmass says do what's in the brackets first. Well, I can't. 2x minus 7 could be any number in the whole universe depending on what x is. So I have no idea what to simplify it to. So the distributive property gives me a little end run around the fact that I'm kind of stuck according to bedmass. Basically, it says I can distribute this multiply into both parts of the thing inside the bracket. So this is 3 times 2x minus 3 times 7. And that, of course, is going to simplify down to 6x minus 21. And you've been doing that, like I said, since about grade 8. Maybe in grade 9, they asked you to do it with more than just a single number in front of the bracket. Maybe the thing in front of the bracket is, I'm going to use a big fancy word here, a monomial, which means it's a piece of algebra, it's a term where I have more than one factor. In this case, I have a factor of negative 2 and x. You could even think of it as 3 factors if you like. It's negative 1, 2, and x. You can always think of a negative as being its own factor of negative 1. Okay, so now I'm going to distribute that through the brackets, and that's going to give me negative 2x cubed. Right? Does everybody get why x times x squared is x cubed? Minus 12x squared plus 8x. Where did the plus come from all of a sudden? Oh yeah, a negative times a negative makes a positive, right? Okay, so again, that's about as far as you got, or that's as far as the curriculum told you had to get in multiplying together pieces of algebra in grade 8 and 9. So example 1 is grade 8, example 2 is grade 9. Here's your first grade 10 multiply. What if you have a binomial times a binomial? What do you do here? Well, you think about it. Oops, I wanted the pen, not the highlighter. You think about this as a double multiply. Think that you're distributing both things in the first bracket into the second bracket. So that's the way you can think about it. So if you think about it that way, I'm just going to make an arrow here and work up here. I don't know why we're so far down. Let's work that out. So x times x is x squared. X times 1 is x. And then over on this side, x times 8 is 8x, and it's a positive, so I'm going to say plus. And 8 times 1 is 8. Now, there's 2 like terms here. Hang on just a second here. Hang on a sec here, guys. Feel free to collect those like terms while I talk to my colleague here for a second. There we go. We're back. All right. So, did you collect the like terms? You know what I mean by like terms, right? Can I add x squared and x? Say that's x cubed? No, wait a minute. X squared times x is x cubed. I can't add x squared to x. Okay? It's just not allowed to be done. This is the way I always explained it to my grade 9s. See if you don't have to write this down, but see if you like this. Say that you had a younger brother or sister who was doing their math, and they were doing decimals, and they went and they did this. You'd tell them, you'd say, well, you made a mistake, right? You added tenths to hundredths. You can't do that. You got to line up the decimal. And then say that they were in grade 7, and they did this. Oops, they'd probably say 2. There. You'd say, well, wait, no, you can't add fractions that way because you need a common denominator, right? And then suppose they were in grade 8, and they did this. Oops, Come on, pen. Nope. To a mathematician, all of those are the same mistake. You added things that aren't alike. You can't add tenths to hundredths. You can't add halves to thirds. You can't add x's to x squareds. But the difference is, I can, of course, make these alike up here somewhere, a pen. I can make those alike. I can just slap a 0 on there and say that it's 0.23, right? I can make these alike by making this 3/6 plus 2/6, which is 5/6. But what do I do with that? It's clearly not this, but the answer is nothing, right? I can't add those together. They're not alike. So that's where algebra is a little different than arithmetic. There's no way around some of the rules. I can't combine those. So back over here, if that little detour made some sense to you, I can't add the x squared, so the x squared is still going to be an x squared. But 1x plus 8x is 9x's. And of course, I can't add the 8. So that's as simple as the answer can get. Now, you can break any multiply of a binomial times a binomial, or a trinomial times a trinomial, or any times of omial times any other times of omial, the same way that I just did this, and think about it that way. But that's not the only way you can think about it. Some people, I think, already have seen this, and maybe you even memorized it with one of those, what is this called, an acronym, where you put together a word. Well, how about BEDMAS, right? BEDMAS is not an actual word. It stands for brackets, exponents, divide, multiply, add, subtract. Maybe you've seen this word too. Have you seen the word FOIL before? When you multiply together a binomial times a binomial, there's 4 different multiplies happening, and this is a word that helps you remember not to miss any of them. F stands for, come on, there we go. I don't know what's going on with this pen, but I'm about to. I don't know. Maybe. I do have an extra battery here. I can try changing it in a minute. But F stands for first times first. O stands for outside times outside. I stands for inside. And then it helps if you spell inside properly. Yeesh. Inside times inside. And L stands for last times last. This is starting to come to some people's recollection. This is actually, if you did this in grade 9, great. It means your grade 9 teacher went a little beyond curriculum. This isn't actually in the grade 9 curriculum anymore. This is the first time you have to do it is in this course. So let's follow through, and let's just re-look at this question using our fancy new language here of FOIL. So the first times the first is where that x squared comes from. So that takes care of that one. Outside times outside. What I mean by that is this is the outside number and this is the outside number. If you were driving it or in driver's ed, you'd make sense of that. Oh yeah, the outside lane, the one closest to the curb, right? So the x times the 1 is 1x. Inside times inside would be this 8 times this x. And then last times last is this 8 times this 1. And notice that gets you the same thing that we had up here. You still have to collect the like terms. My FOIL does not do that for you. And I should point out, the only reason you have like terms is because they were like terms to begin with. This is an x and an x. This is an 8 and a 1. To be fancy, this is a x term and a constant. If you were multiplying together 2 binomials that didn't have like terms to begin with, you wouldn't get like terms in the answer. You get 4 different things. Okay? All right. Let's move on to another example. The same thing, it's just got some negatives this time. So let's try this one. So, first times first. X times 2x is 2x squared. Outside times outside. X times -3. Negative 3x. So again, I'm thinking in terms of FOIL. Inside times inside is -5 times 2x, which is -10x. And last times last is -5 times -3, which is +15. Put that together and you get 2x squared minus 13x's plus 15. And again, none of those are like terms with each other, so you can't simplify it any more than that. Now, like I've said, some of you are clearly I can see in your eyes, I can see by the nodding of some of your heads, even with the masks on, that you did see this in grade 9. So you had a grade 9 teacher who showed you how to FOIL, which is good. Awesome that you were a little ahead. And actually, it used to be in the grade 9 curriculum, and I was in the room, I think, the day it was decided that this shouldn't be grade 9 anymore. And I'll tell you why. Because in grade 9, back in the late 90s and early 2000s, I've been teaching a long time, there used to be a grade 9 provincial exam. And I was actually one of the people on the committee that helped design that exam. And I was always on the committees that marked some of them. Teachers would mark their own, and then every school would have to send in random samples. You'd get a random number or random 10 numbers for your school. You had to take those 10 exams and send them in so that the province could build some data based on different areas of the city and different areas of the province. And I remember that this was, you don't have to write this down. This is just a little story. This was one of the questions. In fact, I think it was like question number 1 of the multiple choice section of the grade 9 provincial one year. It was, and pen, there we go. It was, actually, no, you know what? It was actually a minus. It was a minus. Now I remember it. And of course, it was multiple choice. So here was the answers that you had. So, if you was a grade 9 student in the year 2000 and something, what would you think the answer is? All of the above. All of the above? It's not one of them. And clearly it can't be all of the above. Good guess, though. Can't be all of the above. The right answer is C. And the reason why this got kicked out of the curriculum was because on this particular practice exam that we sent out to, I don't know, 50 schools here in the province, something like 90% of the students picked A, which is wrong. When 90% of the kids that you're trying to aim something at in the curriculum can't do it, one of two things. Either it's just way too hard, or, and this is, I think, the more probable thing, it was near the end of the curriculum and nobody was getting to it. So that was the deal. So the fact that you guys got to it meant that your teacher finished the curriculum and got some extra stuff. Now there's people who have their hand up here. The answer is C, correct? Guys with your hand up. Why is it C? Why isn't it? A kind of seems right, doesn't it? I square the x, and when I square -2, well, when you times a negative by itself, you get a positive. Boy, A seems pretty reasonable. But here, let me convince you, first of all, that A can't be right. If the way algebra works is, if you think two things in algebra equal each other, you should be able to pick a number for the variable, put it in, and both things should still be the same number. So let's say your favorite number was 5. Well, if you plug a 5 into here, 5 minus 2 is 3, and 3 squared is 9. If you plug a 5 into here, 5 squared is 25 plus 4 is 29. And 9 does not equal 29, so something's drastically wrong. But, hey, put a 5 in here, and you get 25 minus 20 plus 4. 5 plus 4 is 9. So this thing does equal C. C is the right answer. What's going on here? I see a couple hands up. I see a bunch of hands up. Okay, I don't want to say people's names because I am recording. So at the back there, what do you think's going on? Oh, you don't get it. Okay. So what part did I lose you at? Oh, where did I get the 9 from? Again, what if x was 5? Put a 5 in here. What's 5 minus 2? 3. And what happens when you square 3? 9. But if I put a 9 in here, or sorry, if I put a 5 in here, sorry, do I get 9 in this expression? No. So they can't be equal to each other. Put a 5 in this one. Can't be equal to each other. Even put a 5 in this one. You get 25 plus 20 is 45 minus, you get 41. No, the only one that works is C. What's going on? Yeah. That is exactly right. You actually should kind of already know this. If you remember grade 9 exponent skills, exponent laws we called them, I think, in grade 9, you had something called, and there's the pen dying again. Oop, there we go. You had something called power of a product that said that if you have an exponent outside a bracket, it distributes to the two things in the bracket, but they have to be either a product or a quotient. There is no such thing, switch to red, there is no such thing as power of a sum law. These two things don't equal each other. And again, pick any numbers you want for A and B except for 0 and 1. 2. Okay, 2 and 3. 2 plus 3 is 5. 5 squared is 25. Does 2 squared plus 3 squared equal 25? No. 8 plus 4 is not 25. So these two things don't equal each other. How come? Because there's no such thing as power of a sum. You can't distribute an exponent into an add or a subtract in a bracket. And that should make sense to you. What does exponent mean? It means repeated multiplying. It doesn't mean repeated adding. That's what multiply itself means. Multiply is repeatedly adding. So exponents don't work that way. So if I actually have a plus b squared, what can I do with it? And now let's go back to your notes. And let's write that down as like a little rule. A plus b squared is like saying take the entire bracket and times itself. And this was the point of that whole long story. It's a FOIL situation. And we had 1 year in the provincial exam where 90% of the kids didn't know that. So clearly their teachers weren't getting to it. And that was actually the problem. The grade 9 curriculum used to be way too long. They trimmed a few other things out of it too. But one of the things they trimmed out was this. The other thing was there used to be some algebra in your power and exponent laws. And now, if you think back, all of your exponent stuff is almost all just numbers. There used to be some algebra in that. They also used to have, way back in the day, they used to have the unit that we're going to do next after this unit. Trigonometry used to happen in grade 9. So they've moved a few things around. Okay, so if that's the case, then this squared does not mean that I can say it's 16x squared plus 9y cubed, or squared, because it is not. It is going to be the answer of 4x minus 3y times itself. If you want, we could even make a little pattern for that. What's this actually going to equal if we FOIL it out? Well, it's going to have an a squared at this end. It's going to have a plus b squared at this end. And then what will happen to the two terms in the middle? It would be 2 times a times b. So let's see if we can kind of follow that pattern. So this is the pattern for, if you like, you could put a little note on this. Put a little note on this. We call this squaring a binomial. You guys know what I mean by binomial, right? It's not a free lunch. No? It means two terms. Two things of algebra separated by add or subtract. So if you have a binomial, two things, a plus b, something plus something, something minus something, and you square it, you have to write it out in this form, and it'll always turn out to be one of these trinomials here. So let's see if we can figure out this one. 4x squared times 4x squared is 16x squared. And I'll do this one the long way. 4x's times negative 3y's is negative 12x times y. Remember, your grade 9 teacher should have told you this. When you have a term that has more than one variable, you tend to put them alphabetical order. So I put x before y. Would it matter? No, but that's the way we usually do it. Okay, so that was outside times outside. Inside times inside is negative 3 times y times 4 times x, which is negative 12xy. Again, if you wrote yx, you're not wrong, but most people write them alphabetically. And then I have negative 3y times negative 3y is plus, right, because negative times negative, 9y squared. Let's look at the two like terms. Can you see them? Right? Those are like terms. 16x squared minus 24xy plus 9y squared. And that's the answer. And notice that actually fits this pattern perfectly. Right? What did I do? I squared the first one. I squared the last one. That's these guys at the ends here, right? And then how did I get this number in the middle? I times the two together and I doubled them. Right? 4x times negative 3y is negative 12xy, but I doubled it, so it's negative 24xy. And that, by the way, is how you were supposed to figure out that it was C in this question. You were supposed to square the first, there, square the last, there, and then times the two together and double it, there. So that's why it was C. But again, I think teachers weren't getting to it. So I remember that was it. They just rounded up all the tests as when we finished marking them, and big meetings happened between people who decide what's in the curriculum, what isn't. And of course, that's across 3 provinces, right? Because we have the same curriculum, well, 4 provinces. It's us, Saskatchewan, Alberta, and BC. We all have basically the same curriculum. The Western Canadian provinces all share curriculum documents. So they all decided, no, we're all having the same problem. This curriculum's too big. What can we move up to grade 10? And this is one of the things they moved up to grade 10. So there you go. Oops, go away. All right. That's a binomial times a binomial. What if it got even bigger? Ugh, I think for this one, can I use FOIL again? No, FOIL only actually works when it's a binomial times a binomial. I think for this one, I'm going to go back to the first method. I am going to go back to x times 2x squared plus 3x minus 4 plus 5 times 2x squared plus 3x minus 4. So I'm basically distributive propertying both numbers. And then I'm going to collect my like terms once I'm done multiplying. So x times all of this will be 2x cubed plus 3x squared minus 4x plus 10x squared plus 15x minus 20. All right, what are my like terms? Yeah, there's nothing that I can combine with the x cubed, so I'm just going to leave it alone. But the 3x squared and the 10x squared can make 13x squared, right? Careful, remember that this negative belongs to the 4. So this and this are like terms, which makes it 11x's. And then the minus 20 has nobody to play with. There's no other constants, so there it is. Okay. I always like to point out when algebra and just basic arithmetic aren't particularly different. Like I kind of started today by reminding you that, hey, it's still bedmath. Bedmath still matters. Well, what would you do in basic arithmetic if you had numbers too big to multiply together just by looking at them? But I'm still not letting you use a calculator, right? Say you actually had, you don't have to write this down, say you actually had a 3-digit number times another 3-digit number. what would you do? Yeah, most of you would probably go to this algorithm right here, right? And do it that way. Right? Put your zeros in it and move things over. Well, guess what? I can do that here. When I start getting into things that are this big, 3 terms times 3 terms, I guess the technical name for that would be trinomial times trinomial. I think, just like if I was working with numbers, I need a little help. I think I'm going to actually do this using long multiplication. I'm going to put one on top of the other. And I'm going to multiply them together. I'm going to put a little x. By the way, I tend not to use x for multiply when I'm doing algebra, because it's so easy to mix up the x and the multiply symbol. But when on the rare occasion when I do, and I guess this is one of them, do notice that I write them different. In my world, this does not mean multiply. Oh, come on, pen. In my world, that does not mean multiply. That is the variable x. And that does not mean the variable x, it means multiply. And I think most textbooks are like that too. Some people like this better for their x. You like that? Good. One way or the other, you kind of have to handwrite it. Okay, so pick one of those for variable. And this, of course, means your pen's not working. This means multiply. Okay? So if you get used to that, people will always tell what you're talking about. Okay, back over here. Maybe back over here. Geez, how do you do this again? Let's refresh our memory. What do we do? What's our first step? Get all this out of the way. Okay, so 2 times 7 is 4. Carry the 1. 2 times 5 is 10 plus the 1 I carried is 11. And then 2 times 4 is 8 plus the 1 I carried is 9. Then what do I do? Yeah, I have to put a 0. Now, why am I putting a 0? Because I'm not really multiplying by 1. I'm multiplying by 10, so I got to start in the tens place. That's important. That's the way I'm going to approach this. So I'm going to start by multiplying all these guys by -2, which gives me 12, but it's a plus 12, right? Why is it a plus? Because it was a negative times a negative. And then it's -2 times -x, which is plus 2x. And then it's -2 times 4x squared, which is -8x squared. And now, and I don't know why I didn't do this, I wonder if I could move all of this over. Oh well, I should have started further over. Come on, move over. Oh, I bet I know I can do this. Watch this. And then oh, but it left all the writing behind. That's no good. I thought the writing stayed on the page when I did it. Oh well. There's probably a way to do it, and I'm just not savvy enough to know it. Okay, you're just going to have to write small, because I wasn't smart enough to start further over. Okay, just like when I'm multiplying numbers, I kind of have to put a 0 here. Question? Oh, I can't hear you. Because what is -2, come on, pen. What is -2 times 4x squared? Get it? That's why it's a -8, because it's a negative times a positive. That help? Okay, so on the next line, there won't be any constants. Just like when I was multiplying regular numbers, there won't be any more ones. I took care of the ones place. I've taken care of the constants place. So now I leave a blank here, but 3x is what I'm working with now. So now I'm working with the 3x, and the 3x is going to multiply by the stuff on the top. So 3x times -6 is -18x. 3x times -x is -3x squared. And 3x times 4x squared is 12x cubed. And now I won't have any x terms on the next one, because I'm starting by multiplying with an x squared. So again, I leave some space. So starting right here, I'm going to have 3x squared times negative 6, which is negative 18x squared. 3x squared times negative x, which is negative 3x cubed. And this is where, come on, move over. No, it won't let me move over. I kind of have to squish in here. 3x squared times 4x squared, which is 12x to the 4. And then I add all this together, just like I do with numbers. Okay, the 12x to the 4 doesn't have anything to play with. It's not going to combine with anything. There's no like terms for that. So that's just 12x to the 4. But here, in this column, you add together columns, right? In this column, what's 12x cubed minus 3x cubed? 12 minus 3? 9x cubed. Then on the next one, I'm going to add together this column of x squareds. Add together that column. I have negative 8 minus 3 more minus 18 more. So in negative 8 minus 3 is negative 11. Negative 11 minus 18 is negative 29 x squareds. Now I need another column. I'll make this column green. I'm going to add together my x's. 2x's minus 18x's is minus, this is the one you were thinking of a second ago, minus 16x's. And the 12 doesn't have anything to combine with. So that's about as ugly as this stuff gets. Now please notice you don't have to do it that way. You could, if you wanted to, alternate strategy. This is why I wanted to work on the left, because I did want to do 2 different strategies. The alternate strategy is to distribute. You could say it's 4, and this to me seems like more work, but I'll show it to you anyway. You could say it's 4x squared times this bracket minus an x times this bracket minus a 6, and I've run out of room this way now, times a bracket.
I very much do not like that one.
It works.
It's a lot more to think about.
It is. It's more terms. You're going to have more to collect at the end. Well, actually, now that I think about it, you'll probably have the same amount to collect at the end. It just won't be nicely aligned in columns for you, right? Which is why most people, when they have to multiply together big numbers, do it this way. Do you have to do it that way? No. You could do what's 300 times this number, what's 10 times this number, and what's 2 times this number, and then add up all the numbers. That's exactly what this method is. But the bigger it gets, the more work it gets. So, I mean, we should get the same thing. We're going to get 12x to the 4 plus 12x cubed minus 8x squared minus 3x cubed minus 3x squared plus 2x minus 18x squared minus 18x plus 12. And then collecting like terms, 12x to the 4, there's a cube, that's plus 9x cubed. There's a squared, minus, something's wrong here. Oh, I missed a squared, there's a squared. So negative 8 minus 3 is negative 11, minus 18 is minus 29x squared. And then there's an x and an x, minus 16x plus 12. Okay, let's compare. Yep, we got it. But again, I feel like that was more work. Right? This took me longer to explain, but to actually do it felt faster. Your mileage may vary. If you like this better, I'd never stop you from doing it that way. You want to know the easiest place to goof it up this way, though, is careful. And I guess, you know, to a certain extent, the left side has the same problem. You have to watch negatives. Did you notice that this is a negative here that you have to distribute through every multiply? It's always negative x times those 3 numbers. It's always negative 6 times those 3 numbers. Right? Same thing happened here, right? It was negative 2 times all these numbers. Somebody even asked, hey, why did this become a negative? Because I multiplied 4x squared by negative 2. So you got to watch that. Okay. Do people spend a lot of time on the internet?
Yes.
On the interwebs, as they say, the kids these days say? Ever seen stuff like this, where you have somebody asks you, what is your answer if you get this? This one's very popular. Come on, Pan. There's people who swear that the answer to this, actually, maybe I should make that a bigger number. There's people who swear that this answer should be 9. And I don't see a 9 there. There's people who think that should be a 9. Do you get why they think it's a 9? Because they go 6 minus 3 is 3, and 3 times, do what's in the bracket, 3 times 3 is 9. But that's not how BEDMAS works. BEDMAS says you have to multiply before you subtract. So I would say that this is 6 minus 3 times 3, and 3 times 3 is 9, so this is 6 minus 9. This should be negative 3. Usually I can convince people that that's true, and they'll go, oh yeah, you're right. I can't do that subtract first. But then, this is the one that really gets them. What if this, instead of being a times, had been a divide? Now, I still think that the divide happens before the subtract. So if you ask me what that answer is, I'm going to tell you all day that's a 5. Right? BEDMAS says do the bracket first. That's 3. So 6 minus 3 divided by 3 is 6 minus 1 is 5. All day long, to me, that's a 5. But you're going to get people out there who would say, no. They have to do the divide before, or no, let me see. How do they do this? They have to, They do the subtract first because they think of it like this. Yeah, they do the subtract first. Let me see, have I got this going right? Yeah, they do the subtract first because they think of it as 6 minus, yeah, they think of it like this. They think of it like this. Right? They think of it like that. And I don't think that's the right way to think about it, but apparently there was a time when that was the way you think about it. There was a time, roughly 100 years ago, when this symbol meant, this divide symbol that you guys know well and love, meant everything to the left is on top and everything to the right's on the bottom. So people who actually come up with this answer and swear that they're right, basically are doing 100-year-old math. We don't think about that symbol that way anymore. We don't have to, because we can actually, when we type and use word processor, we can just put things on top of other things, and it's easy to do. We don't have to just assume that the symbol means everything on the left's the top and everything on the right's the bottom. So, weirdly enough, though, there are some calculators that will even goof this up. I think this is 5. Anyway, the reason that popped into my head is because, clearly, what is happening here is the multiply has to happen first. So this is 3x minus 2x minus 2. Where did the minus 2 come from? I distributed, I should say, negative 2 into this bracket. And now I have like terms, and that's x minus 2. Notice this one is kind of more work, but it's still the same basic idea. Okay, so let's roll through it. X times x, first times first, is x squared. Outside times outside is minus 3x. Inside times inside is minus x. Last times last is plus 3. Minus 4x squared minus 8x plus 12. And where did the plus come from? Make sure that makes sense to you. I have some like terms to collect. I have 1x squared minus 4x squared. That's minus 3x squared. I have minus 3x minus another x, which is minus 4x. Minus 8x is minus 12x. And I have 3 plus 12. What is 3 plus 12? That's 15. It does. One of the more common mistakes people will make is they'll go, how come you didn't get -9 instead of plus 15? I'll say, where did you get -9 from? And they'll go, oh. They'll say, because I went 3 minus 12. It's like, no, 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 no. That sign doesn't belong to the 3. It belongs to this 4, right? So make sure that makes sense to you. I see that mistake a lot, actually. All right, and example 10 is more of the same. We're going to FOIL that. So 2x times x is 2x squared. Oh, hang on, I don't have the pen on. 2x squared. 2x times -2 is -4x. -1 times x is -x. -1 times -2 is +2. Now, I'm going to do this in 2 steps. I am minusing this multiply. So I have to do the multiply first. So I'm just going to open a bracket and put the answer to the multiply in it so that I don't lose track of the fact that all of it has to get affected by this minus. So that's first times first, outside times outside, inside times inside, and last times last. I might even do another step where I collect like terms right here to make my life easier. 2x squared minus 5x plus 2, and then in this bracket, x squared minus 1x minus 20. Now, I'm going to distribute this -1 through the bracket. This stuff you did do in grade 9, subtracting polynomials. Chances are you had a grade 9 teacher who told you, you should probably take the time to make this step happen. Distribute the subtract first, then collect your like terms. And there's people who go, but it's a whole extra line of writing. You know, it's just so much work. Well, you know what? I'll tell you something. If you can get to the final right answer, if you can get to that answer from here, skipping that step, okay, you're in grade 10 now. I won't tell you what to do that much. Go right ahead. But this is where you got to kind of be aware of your own learning. If you find that you're doing questions like this and over again you check the answer in the back and you're not getting it right, that should be telling you maybe I should go back and put this step in because I don't have the ability to juggle that many things in my head and not goof them up. Maybe after you've done them for a while, right? You'll get better. This stuff, you get better at it the more you practice it, like any skill in life. Okay, we're getting low on time, so that's the lesson. I told you it was a bigger lesson today. Well, and I slowed down to tell stories. And tomorrow, I'm not going to assign anything different or do any new lessons. Tomorrow, you're going to get some work time, but you're also going to get, okay, I'm going to stop the recording now.